is going to be our lecture video for November 11th through 12th. Let's go ahead and get started. Copy down this problem into your notes. And I want you to try this one on your own. So I'm going to embed the question here. All right, and here's the full solution for that. Notice I had to do 5 times 24 and get 120, and then split that into a 15 and an 8, which still multiply to be 120 and add to be 23. Then I split apart the middle term, grouped the first terms and the last terms, pulled out the greatest common factor, and then rewrote it. Because it was set equal to 0, I could use the zero product property, and you can do this last step in your head if you're okay doing 2 steps in your head. You just set this equal to 0. Subtract the 8 over, divide by 5, you get negative 8/5, and for this one you get negative 3. Okay, our goal for today is to be able to solve quadratic equations by completing the square and using the quadratic formula. While we're doing this, both of these techniques are good for unfactorable quadratics. So instead of doing factoring by grouping, if you're solving, you could use one of these techniques. All right, so we'll start with completing the square. So this is very similar to converting to vertex form. So if you still remember how to do that, then this is going to be a walk in the park. All right, your goal, so I'll write this down, is to get one side to be a binomial squared so you can take the square root of both sides. All right, so I look at just these two terms here, and I want to rewrite that as some binomial squared. So I'm going to do x plus 6 squared, and it's just like converting to vertex form. It's always half. It's always half b once you get your a value to be 1. All right, this will do a good job of giving me an x squared back and a 12x back, but it's also going to give me an extra 36. So I'll subtract the 36 away, keep the minus 18. All right, so now that is equivalent to that. But now here's where it's a little bit different. What we want to do is move these constants to the other side. So we'll combine them first. Negative 36 minus 18 is a negative 54. But I said I wanted the whole side to be squared, so I'm going to move this 54 to the other side. So I'll add 54 to both sides. And now I've got x plus 6 squared equals 54. So what I'm allowed to do is, because the entire side is squared, I can take the square root of the entire side, and it will cancel out that squared. And that's going to give me, so on this side, the square root cancels out, and I'm just left with the x plus 6. And on this side, I get the square root of 54. And I'm going to emphasize that square roots are positive and negative by putting an extra little plus or minus in front. It is implied by the square root, but you'll see why I want that there. So x is still not by itself, but it's a whole lot closer. Let me just subtract 6 from both sides. And I'm going to be left with x equals negative 6 plus or minus the square root of 54. Put that negative 6 in front of the radical, because normally if we have to leave a radical in our answer, we want it at the end. So x equals negative 6 plus or minus 54. And I'm fine with the plus or minus, or you could break it out into negative 6 plus the square root of 54, and negative 6 minus the square root of 54. And we'll just leave it like that. Don't worry about simplifying radicals yet. I'm not sure if this one could be simplified. I think it probably could. Yeah, we could take out a 3, but don't worry about that. Just leave it like this. All right. Let's try it again. If you feel up to it, pause the video and try this one on your own. Otherwise, I'm going to rewrite this part here as x minus 7 squared. Get rid of the extra. Keep the plus 40. X minus 7 squared minus 9 equals 0. Add the 9 to both sides because I want the whole side to be squared. X minus 7 squared equals 9. Now I can take the square root, and this one's nice because 9 is a perfect square. So I get x minus 7 equals plus or minus 3. Let's move that 7 over, so plus 7. And I get x equals 7 plus or minus 3. But when that's an integer, just do split this one apart into x equals 7 plus 3 and x equals 7 minus 3, and get the two integer solutions, x equals 10 and x equals 4. All right, plugging back into double check. One more. This one, there's a 9 on this side, but because we're not trying to use the zero product property, that doesn't matter. I'm going to go straight into trying to represent this as some binomial squared. So I don't like that 4 in front, so I want to divide everything by 4. And let's just see, negative 9 plus 105. That is divisible by 4, so actually the better first step is add 105 to both sides. 4b squared plus 8b equals 96. And now divide everything by 4. And 96 is divisible by 4, I think. Yeah, we get 24 on that side, so b squared plus 2b equals 24. And then I want to rewrite this as b plus 1 squared minus 1 equals 24. Add 1 to both sides. And we get b plus 1 squared equals 25. Let's take the square root of both sides. And we get b plus 1 equals plus or minus 5. Subtract 1 from both sides. b equals negative 1 plus or minus 5. Split it into the two cases. b equals negative 1 plus 5. b equals negative 1 minus 5. And get your final two answers. b equals 4 and b equals negative 6. So it worked for this problem, but you might have noticed maybe back here I could have moved the 24 over and this would have factored into a b minus 4 and a b plus 6. That would have been a little bit faster, but it still works. If you just want to learn this method, you could actually avoid factoring for a lot of problems. Although factoring is faster, so you should still know how to do it. All right, let's talk about the quadratic formula. In order to use the quadratic formula, you need to get your quadratic into standard form set equal to 0. Then you can use this. Or we can just use the values for a, b, and c in this formula, which you should copy down right now. All right, let's use it on this problem. Here, the a value equals 1. There's no leading coefficient. The b value equals negative 5, and the c value equals negative 6. Let's plug those into negative b plus or minus the square root of b squared minus 4ac all over 2a. And the more you can do in your head, actually, the better. I know a lot of math teachers don't want you doing too much in your head, but when I see negative b and I see b as a negative 5, I'm just going to go straight to turning that into a positive 5. Negative 5 becomes a positive 5. Plus or minus the square root. B squared. Well, b is a negative 5, but I'm going to square it. It's going to become a 25. Negative 5 times negative 5 is 25. Minus, and if you can do this next part, it is helpful. 4 times a times c. So 4 times 1 is 4. Times negative 6 is going to be a negative 4. So minus a negative 24. All over 2a. 2 times 1 is 2. All right, the minus and negative becomes a plus. That there becomes a 49. So 5 plus or minus the square root of 49 all over 2. 5 plus or minus 7 all over 2, which split this into the two cases, 5 plus 7 over 2 and 5 minus 7 over 2 gives us 12 over 2, which is 6. We should now write it with an r equals 6, and negative 2 over 2, which is negative 1, r equals negative 1. Again, this one was actually very easy to factor. We could have done an factored it into r minus 6 and r plus 1, and we would have gotten the answer a lot faster. But kind of like completing the square, quadratic formula will always work. All right. What should we do about this one? Well, it's not in quadratic form yet. So I'm just going to subtract 3x squared from both sides to get 0 equals negative 3x squared plus 3x minus 10. And now we can plug it into quadratic formula. So negative b, so negative 3 plus or minus the square root. B squared, 9, minus 4 times a times c. Negative 3 times negative 10 is a 30, times a 4 is a negative 120. All over 2 times a, so 2 times negative 3 is going to be a negative 6. And then we get negative 3 plus or minus the square root of negative 120, 111. Is that what that is? 9 minus 120, negative 111, all over negative 6. But we can't take the square root of a negative, except for now we know about this idea that I equals the square root of negative 1. So we can pop this negative out as an I, and we're going to rewrite this as negative 3 plus or minus the square root of 111I all over negative 6. Here, the negatives could actually cancel. And we could distribute that divide by 6, but I'll just cancel the negatives and call it 3 plus or minus the square root of 111I all over 6. And I think that that's a fine answer for this one. All right, so essentially if you see a negative inside a square root, pop it out as an I at the end. All right. I'll embed a few more questions here, but that's that for this video. Have a good rest of your day.